Welcome to the second session of numerical control. The numerical control systems are further classified into open loop control systems and closed loop control systems. First, we will consider the open loop control system. So these control systems are normally use stepping motors as the drive devices to move the machine slide. Due to the advent of precision ball screw and stepping motor control technology, open loop control can be refined to 0.001 in resolution, and approximately that is 10 micrometer, which is accurate enough to be used in many precision positioning and light contouring applications. So the highlight is that this system is used for light machining applications, because stepping motors can take these are of the smaller capacity, so it can be take light loads. That is the main disadvantage of these kinds of systems. And the picture shows the line diagram of an open loop control system. So we are considering a slide which is having an x-axis movement and a movement in y-axis. So separate stepper motors are used for x-axis and y-axis. So this movement of stepping motors is governed by the control system, and in the open loop control system we are not employing any feedback systems. So this system is a simpler one and less costlier, but the capacities will be less. The working of open loop control system can be explained like this. This one is the CNC controller, and it has got input output devices, and a communication port is there, and operator interface is there. Through the operator interfaces we are actually feeding the program. The operator programmed program is known as the part program, and while it is processed in the microprocessor, then the command signal generator generates the signal required signal, and that signal is amplified and that is given to the stepping motor. And as said earlier, there is no feedback device, so there is no way to verify whether the slide has moved the determined distance or not. The second type of control systems, that is the closed loop system. Here we are employing a feedback loop to monitor the actual output and correct any discrepancy from desired outputs. So both analog type and digital type can be applied. So most modern closed loop NC systems are available to provide very fine resolution of 0.0001 inch or up to a resolution of 1 micrometer. The picture shows the setup of a closed loop control system. So here we are using two kinds of feedback systems. That is, one is the tacho feedback and another one is the solver. So this tachometer is actually used to verify the velocity feedback. That means the velocity of rotation of the motor, whether it is correct or not. Then another one is the resolver, which is actually taking the feedback of the position. That is a displacement of the table, whether it is reached the required distance or not. So these two are actually taken as a feedback, and these feedback signals are fed to comparators. So these two units are known as comparators. So comparator, the input is fed with a voltage from the controller, and the feedback is also providing a voltage. If these two voltages are same, there is a difference between these two voltages. So say this is the reference voltage is VC and VF is the feedback voltage. If these two voltages are same, then the difference between these two will be 0. Then there is no control is required. Everything is correct. And if there is a change, whether it is a positive change, or because if VC is higher, it has to be assessed that there is some problem. Maybe the required distance is not achieved, or the required velocity is not achieved, then the corrective action has to be taken using this error command, and that is get amplified and that is fed to the axis motor. So the corresponding corrections will be applicable, or the corresponding corrected signal will be fed to the motor, and that will be corrected. That is the function of this closed loop systems. Here we are discussing about CNC interpolation and its functions and its various classification. So the functions are two functions. One, it computes individual axis velocities to drive the tool along the programmed path at the given feed rate. Second one is that it generates intermediate coordinate positions along the programmed path. And there are 5 types of interpolation, that is linear interpolation, circular interpolation, helical interpolation, parabolic and cubic. So the interpolation is applicable whenever we can have a combined motion along 2 axes or more. It is not applicable to point-to-point system or single cut system. So considering the linear interpolation, so linear interpolation is applicable whenever the tool path is at a slanted tool path is required in between x and y directions. So the input will be the velocity of the tool path in this direction and the angle of the direction. Okay, so these are that is angle of inclination. So these are the two inputs. From these inputs, the computer processor has to calculate what is the distance moved in y-axis and what is the distance moved in x-axis. Then also it has to compute what will be the velocity of in y-axis and what will be the velocity in the x-axis. So that has to be done with the CNC controller of the machine. So linear interpolation requires 3 parameters, that is start point coordinate, end point coordinate, and the speed command for each axis. The 2-axis linear interpolation, the interpolator calculates the speed commands in pulse per second for x-axis and y-axis in such a way that it maintains the speed ratio between x and y-axis equal to the ratio of the required incremental distance dy by dx. And in circular interpolation, we have to interpolate the points between from start point and x that end point. So it is also having x-axis and y-axis. If for a curve like this, there is no curvy motion for the tool. It is actually the curve motion is obtained by combining the linear motions like this. So it will have fine linear motions for combining these two axes like this. So it will appear like a curve. So this point has to be interpolated, and also it has to determine what will be the velocity of y-axis motor and what will be the velocity for the x-axis motor. So this process is known as circular interpolation. The information required for circular interpolation includes coordinates of start point and end point, radius of the arc or coordinates of the arc center, and the direction in which the tool is to be proceed. That is either whether it is in clockwise direction or it is in counterclockwise direction. So in this picture, you can see that these are the governing equation for x and y coordinates of each and every points, and the velocities computed using this relation. The helical interpolation, which combines the 2-axis circular interpolation, just like discussed earlier, and it also combines a linear interpolation along the 3rd axis. So 3 axes are actually working in helical interpolation, that is x, y, and z. So either any two axis we are doing the circle interpolation, and in the third axis we have got a linear interpolation. Then it will be a helical interpolation. In parabolic interpolation, it uses three non-collinear points to approximate freeform curves. So we can consider this curve. So these points P1, P2, and P3 are defining the curve 1. This is the first curve. And the second curve is defined with the 3 points P3, P4, and P5. This is our second curve. And again, the third curve is actually defined using the points P5, P6, and P7. So these curves are known as freeform curves, and the application is in making of mold and die making, then where freeform designs are preferred over precisely defined shapes. And finally, in cubic interpolation, this is of the third order and can be used to generate complex tool path for machining complicated shapes such as automobile sheet metal dies with a relatively small number of programmed points. However, it is very complex and requires considerable computing power and large memory. Thank you for watching.